Hi, it's Mrs. Golding. I am in your math packet on page 18, and we are on the second problem, problem number 2. And I have gone to Desmos.com, which is, again, great resource. Hope you're trying it out. You have in your packet that Donnie created a triangle. And so I created Donnie's triangle on Desmos here using a table. So his ordered pairs are 2, 3, 2, 5, and 7, 3. Okay, so here's his triangle. Here's those 3 points that he had. And it says that Stuart created a triangle on the same coordinate plane using these values. Okay, so I'm going to bring them up. -4, 5, -4, 7, -9, 5. What kind of triangles did both Donnie and Stuart make? Do you remember what those are called? Those are right triangles. And if I were to draw them, I'm going to start with Donnie's, going to connect his points here. Oops, that didn't work so well. You can imagine. And then I'm going to do the same thing here with Stuart. Okay. Again, not perfect, but okay. The question is, do the triangles have the same area? Okay, so if we look closely at Donnie's triangle here, I'm going to zoom in on it so that we can see it here. Let's see. I'm going to bring it over here. Oh, we don't want to do that, do we? Because it moves the whole thing. Let's count on the base of Donnie's triangle from the first point here to this next point here. And let's see if I can grab that here. So this point right here. Okay, we're going to start down here. 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10, and then the height of this triangle. 1, 2, 3, 4. 10 times 4. That is 40 square units, right? I could write that here. 40 units squared. It kind of got funny. 40 units squared. Probably better to not put 40 squared. It's 40 units squared. Okay, so if we look at Stewart's, let's count the base of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the height 1, 2, 3, 4. They have created triangles that are congruent, 40 units squared. Now, the cool thing that you're going to focus on with this in 8th grade are transformations. And you can kind of see that there's a transformation that happened here, but it's actually a couple transformations. And here's what I mean. If you took Donnie's triangle right here and you flipped it, okay? So we're going to just flip it, and we're going to flip it across the y-axis. Now notice that would end up with this point right here, this point right here, right? And then we could count 10 over for that other point. Notice what we did was we reflected it across the y-axis, and then we did something called translate. Not like English to Chinese, but we translated it to the up, and to the left to get that triangle right here. It's congruent. So it's the same figure, it's just been translated. And when we just translate the same figure, when we transform the same figure, it maintains its area, unless we're dilating it, which we're not. Dilation is a transformation that makes it smaller or bigger. So we learned something new today. Donnie and Stuart have the same, have two congruent triangles with the same area. Have a great day.